recording it now. Hello, everybody, and thank you all for coming for 2022's first lecture of a Symposium of Aristotelian Studies. I am Professor Daniel Simão Nascimento, the organizer of the symposium, the host for this meeting. As usual, I'd like to thank FAPERJ, CAPES, and CAPES for their financial support, and the members of the research groups Pragma, Uzi, and Polyphonia for their academic support. For those of you that are joining us for the first time, let me brief you quickly on our protocol. The lecture will be delivered in full. Then we'll have a round of questions from our debaters before moving on to any questions from the audience. In order to avoid any possible technical problems, I'll ask everybody to keep their cameras and microphone turned off during the presentation. And if you have any questions, that you not only raise your hand, but also say so in the chat so I can keep up with who's supposed to go first. Speaking of the chat, let me remind everybody that the handout for the session is there and that those of you who need certificates should fill in the form that is also made available there. Today, we're joined by Professor Diana Quarantotto, who is delivering the lecture titled Physical Arguments for the Non-Physical Principles of Nature in Aristotle's Physics 8. And to debate this lecture, we have Professor Lucas Angioni and Roberto Grasso. So let me briefly thank them all for joining us today. And without any more delay, welcome Professor Quarantotto to our Symposium of Aristotelian Studies. Diana, thank you very much for accepting our invitation. The floor is yours.
Thank you. Thank you for inviting me to this symposium. I'm very pleased to be here and very grateful for the opportunity to discuss my work. The draft I sent is part of a bigger project on the physical background of Aristotle's first philosophy. And the draft is about Physics 8 as a whole, and it is an attempt to answer the question, how does Aristotle arrive at a non-physical entity by using physical arguments? Indeed, Physics 8 comprises a sequence of arguments that is based on physical premises and that leads to the first cause of nature, which is not itself a natural entity and is not an object of natural science, but a first philosophy. In this book, Aristotle describes this first cause of nature as a mover that moves always, that is a move per se and per accidens, that is endowed with an unlimited power and that lacks parts and magnitude. Now, the question I try to answer has not been raised so far, as much as I'm aware. Concerning Physics 8, several scholars speak of the physical foundation of theology or of the transition from physics to theology, but no one has ever asked how Aristotle arrives at something non-physical from physical premises. However, this question seems to me relevant both in itself, that is from a logical and epistemological point of view, and for its potential usefulness for understanding the non-physical status and properties of Aristotle's first cause. Understanding how Aristotle's physical premises lead to something non-physical can give us means to better understand the meaning of the properties that Aristotle in Physics 8 attributes to the first cause, because it amounts to understanding what kind of reasoning and operations they derive from. Now, my proposal is that the main heuristic and argumentative tool whereby Aristotle arrives at a non-physical entity from physical premises is a series of inferences from limited to unlimited changes. Thereby, I mean the application to unlimited changes of properties and theses that Aristotle elaborated by inquiring into limited changes, and whose meaning is originally linked to limited changes. This application or extension from the limited to the unlimited brings about a modification of some properties involved in the inferences. And this modification is of such magnitude as to lead outside the domain of physics. In short, Aristotle develops the notion of first cause of nature using the conceptual resources of his physics. But what these conceptual resources, once extended from the sphere of the limited to that of the unlimited, and in particular, once applied to the mover of an unlimited change, are modified with the result of no longer having a physical meaning. So let us start with the broad plan of Aristotle's argument in Physics 8. This comprises the following inferences. And this is point 1 of my handout. First, from a single limited change to an unlimited chain of limited changes. that is, to the thesis that change is eternal, in the sense that there always was and will be some limited change. Second, from an unlimited chain of limited changes to at least one numerically unitary and unlimited change. And third, from a numerically unitary and unlimited change to one eternal mover that moves always, that is unmoved per se and per accidents, that is endowed with an unlimited power and unlacks parts and magnitude. I shall focus on step 2 and 3 and argue that step 2, namely the hypothesis of an unlimited change, is accomplished by extending the notion of kinesis from limited to unlimited processes. And that step 3, namely the inference from an unlimited change to a mover that is a non-physical entity, is accomplished by applying to the unlimited change theses that are valid for limited ones. Now we need to tackle limited changes first. These are the starting point of Aristotle's inquiry in Physics 8, as well as in his entire physical investigation, arguably because they are evident objects of our experience. He considers it a fact that at least some entities alternate between motion and rest, and on this basis, he maintains that all the views that deny the existence of limited changes are false. And this is point 2 of my handout. Against all the views, one piece of evidence, against all these views, one piece of evidence is sufficient. We see that some things are at one time in motion and at another at rest. So it is evident that both the view that all things are at rest and the view that all things are in continuous motion are just as impossible as the view that of all things, some are always in motion, while others are always at rest. Further, Aristotle maintains that the limitedness of the changes of our experience is not an accidental, but a necessary feature of them. In his view, limited changes are such not because something accidentally interrupts them, but because, given their nature, it is impossible for them to proceed ad infinitum. As we're now going to see, the reason why they cannot proceed ad infinitum is that they unfold between contraries or opposites. Now, the thesis that change unfolds between contraries or opposites is repeatedly stated by Aristotle throughout his writings, starting from Physics 1 and before that from the categories. However, it is neither immediately evident nor always made explicit by Aristotle that unfolding between contraries or opposites implies being limited. And so far as the physics is concerned, this becomes clear in chapters 7 and 8 of book 8, when he states that all sublunar changes, since they unfold between contraries or opposites, cannot proceed ad infinitum. To proceed ad infinitum, they should proceed repeatedly back and forth from one contrary or opposite to the other, but this would not yield an unlimited and numerically unitary process, since going back involves a pause and therefore an interruption of the change. And this is point 3 of my handout. All motions and changes are from opposites to opposites. So if it is impossible for something to change in opposite ways at the same time, change will not be continuous, but there will be a time interval between the changes. And on this point 3, you will also find a sketch that tries to illustrate this point. Further, a change that unfolds between contraries cannot proceed ad infinitum in a straight line either. For as Aristotle stresses in Metaphysic Iota 4, it is impossible to proceed beyond contraries, as the contrariety is the maximum difference within a kind. Lastly, and more generally, Aristotle maintains that it is impossible for something to move towards a telos it cannot reach, which, at least at first sight, seems to rule out the possibility of any unlimited change. Aristotle makes this claim in several passages, including passages from Physics 8, which suggest that this is a fundamental, not a dispensable claim of his. Here is an example from On the Heavens, point 4 of my handout. But this is impossible, namely a local rectilinear unlimited change, if we are to posit that our first assumptions are true, and that what moves downward cannot possibly move without a limit, nor in accord with the same argument can what moves upward. For it is impossible for what cannot have come to be to coming to be, alike in quality, quantity, and place. I mean that if it is impossible for a thing to have come to be white or a cubit long or in Egypt, it is also impossible for it to coming to be any of these things. Therefore, it is impossible even to move toward a place where no moving thing can arrive. In Aristotle's view, a thing cannot always be becoming hot or moving up. And if it alternates between becoming hot and becoming cold again, there must be a time of rest in between. This point is no more small thing, for it informs some basic distinctions, principles, and definitions of Aristotle's physics. Here I shall focus on the distinction between substrate, privation, and form, that between potentiality and actuality, and the definition of kinesis. Aristotle introduces the distinction between substrate, privation, and form in Physics 1 through an analysis of change conceived as unfolding between countries. And he understands the pair privation and form as a contrariety, indeed as the first contrariety. Similarly, Aristotle introduces the distinction between potentiality and actuality to explain the change between opposites, between countries. That is, to explain how a movable body can be both contraries, one in actuality and the other in potentiality. For instance, cold in actuality and hot in potentiality. Lastly, also the definition of kinesis seems to apply to limited changes alone. And this is suggested by at least 3 data. First, while preparing his definition of kinesis in Physics 3.1, Aristotle stresses the change unfolds between 2 states, conceived as form and privation and as contraries. Second, he underlies that the subject of change is an entity that is both in potentiality, one contrary, and in actuality, the other contrary, as opposed to entities that are all only and always in actuality. Lastly, he claims that change is something incomplete that proceeds to our completeness, that is, towards the final acquisition of a telos by the subject of change. And this process of completion cannot be unlimited because, as already stressed, it is impossible to proceed beyond countries. It is impossible to go back and forth from one country or opposite to the other without interrupting the change. And more generally, it is impossible to proceed towards a telos that can never be reached. So the incompleteness of change, which is implied by the definition of change, implies in turn the limitedness of change. Aristotle underlies this point in Metaphysics Theta 6.2, when he distinguishes between kinesis and energia. He claims that kinesis is incomplete, for it unfolds between limits, perata, and therefore it stops once it has reached the telos. Now, that said, it is well known that in Physics 8, Aristotle argues for the existence of an unlimited process, which he calls change, kinesis, indeed the first change, and identifies with the eternal rotation of the heavenly spheres. So the problem is to understand how Aristotle arrives at this conclusion, given his above-mentioned view on change and its being necessarily limited, and why he does so instead of conceiving an unlimited process as something other than a kinesis. Now, on the issue whether the sphere's unlimited rotation is really a kinesis or not, interpreters have been traditionally and continue to be divided. Some raise the problem without solving it. Others say that it is not a local kinesis, but a different kind of kinesis or process without apparently specifying which. Others say that it is not a kinesis, but an energia. Others that it is a kinesis, but an abnormal one, either because it does not unfold between countries or opposites, or because it has some properties of the energia which are incompatible with the definition of kinesis. As we're now going to see, these proposals do not fit what Aristotle states in Physics 8 and elsewhere. He understands the heavenly sphere's unlimited rotation neither as a process different from the kinesis, nor as an abnormal kind of kinesis. Rather, he applies the notion of kinesis to it, to the unlimited rotation, considered in a certain respect. Now, Aristotle's argument for an unlimited change breaks down into two main parts. Firstly, in chapter 6 of book 8, he infers the hypothesis of an unlimited and numerically unitary process from an inquiry into limited changes. In other words, he poses an unlimited process as a necessary cause of the unlimited sequence of limited changes and of the eternal alternation of generation and corruption of sublunary entities. Secondly, and this is relevant to our inquiry here, in chapters 8 and 9, he argues that an unlimited process conceived of as a local kinesis that goes on continuously is possible. And this is point 5 of my handout. For we must consider whether it is possible for some change to be continuous or not. And if it is possible, what change this is and which of the changes is first. This is significant, for it shows that in Aristotle's view, the possibility of an unlimited kinesis cannot be given for granted and must instead be argued for. Now, let us consider this piece of reasoning in detail. In chapters 7 and 8, Aristotle excludes the possibility that substantial, qualitative, quantitative, and rectilinear local changes are unlimited. And he does so on the grounds that they unfold between countries or opposites, and so cannot go back without a pause, and therefore without an interruption of their continuity. Next, Aristotle states that there is a process whose continuity, understood in the sense of proceeding continuously and uninterruptedly, does not involve anything impossible, the rotation of a sphere. And this is because the complete rotation of a sphere does not unfold between countries or opposites, but from a point A towards the same point A. And this is point 6 of my handout. The circular motion, however, will be one and continuous, for nothing impossible results from it. For the thing that moves away from A will be moving towards A according to the same purpose, since it is in motion to the point at which it will finally arrive. But it will not undergo contrary or opposite motions at the same time. Further, in chapter 9, Aristotle adds that unlike a limited kinesis, an unlimited rotation is such that all its points are indefinitely arche, meson, and telos. So the process goes on continuously because the telos, being also an arche, a beginning, is not a peras, a limit, strictly speaking. Therefore, reaching the endpoint, the telos, does not amount to interrupting the process. And this is point 7 of my handout. For the motion along a straight line has a beginning, an end, and a middle point, which are definite. And it contains them all in itself, so that there is a point from which the moved will start moving and a point where it will finish its motion. For everything rests at its limits, whether its beginning or end point. But the point of the circumference are indefinite. For why should any point of the line be more of a limit than any other? Each point is at once beginning, middle, and end. In sum, an unlimited process is possible, provided that its subject is a sphere and that the process at issue is its rotation. For the rotation of a sphere, unlike limited changes, unfolds from one point to the same point, and is such that all its points are indefinitely beginning, middle, and end. Now, it is important to know that these descriptions of the circular process serve to highlight that its unlimitedness does not violate the principle that every change unfolds from something to something, ektinos eisti. Respecting this principle is equivalent to respecting the thesis, which apparently is fundamental for Aristotle, according to which it is impossible for a body to move towards a telos it can never reach. If Aristotle renounced this thesis, he would open the way to unlimited substantial, qualitative, quantitative, and rectilinear local processes. In short, the unlimited rotation of a sphere would no longer be an exception. However, these descriptions of the circular process do not imply that it is a kinesis, quite the contrary. As Aristotle stresses, just insofar as each of its points is indistinctly arche, meson, and telos, the unlimited rotation of a sphere is complete, teleios, whereas from the definition of kinesis, it follows that change, kinesis, is incomplete, ateles. And this is point 8 of my handout. The motion of the circle connects the limit with the beginning, and it alone is complete. Now, as already mentioned, a change is incomplete because it unfolds between extremes that are contraries or opposites, and because the movable body during the change does not yet have the telos it will have at the end of the change. Instead, a circular process is complete because each of its points is arche, meson, and telos indefinitely. Therefore, a circular process is such that its subject, unlike the subject of an incomplete and limited process, is always in the same state. As Aristotle stresses, qua rotating, a heavenly sphere does not change place, but is always in the same place. And this is point 9 of my handout. For the sphere occupies the same place. Now, in the face of this, one might wonder on what basis Aristotle labels the circular process of a sphere as a change, a kinesis, indeed as the proto-kinesis, the first change. Now, Physics 8 does not provide an answer to this question, but it does point to the answer Aristotle gives in Physics 4:5, which is specifically about the place and locomotion of the heavenly spheres. In Physics 8, Aristotle confines himself to suggesting that the unlimited rotation of the heavenly spheres is in a sense a change, whereas in another it is not, since he claims that a rotating sphere is both moved and somehow at rest. And this is point 10 of my handout. For each point is at once beginning, middle, and end, so that the moving body is at the beginning and at the end, always and never. And that is why a rotating sphere is moved and is somehow at rest. And then he adds later, the whole is somehow always at rest and is moved continuously. Now, the hypothesis that the circular process of a sphere is in a sense a change, whereas in another it is not, is confirmed by Physics 4:5. There, while tackling the place and locomotion of the outermost heavenly sphere, Aristotle makes the following claim, and this is point 11 of my handout. The whole spherical body will, in a sense, move, and in a sense, not. Now, unlike in Physics 8, in Physics 4:5, Aristotle explains why the circle of movement of a sphere is, in a sense, a change, whereas in another it is not. He stresses that a rotating sphere does not change place as a whole, and then he accounts for its location and circular locomotion by distinguishing between being in a place per se, or according to the whole, and per accidens, or according to the parts. His idea is that insofar as a rotating sphere is concerned, what is in a place per se and what changes place per se is not the whole sphere, but its parts, which implies that the whole sphere can be said to be in a place and to change place accidentally, that is, according to its parts. And this is point 12 of my handout. Again, some things are in a place in respect of themselves. Other things are in a place accidentally, like the soul and the heavens. For all of their parts are in a sense in a place as one part surrounds another on the circle. So its parts will move since they are surrounded by one another, but the all will in a sense move and in a sense not. For considered as a whole, it does not change place altogether, but it moves in a circle, for this is the place of the parts. And again, on point 12, there is a rough sketch that illustrates or tries to illustrate this point. Now, the parts of a heavenly sphere are in different places at different instants. Further, as Aristotle specifies in Physics 8.8 and elsewhere, all the places that are extremes of the diameter can be conceived as contraries. So he understands the motion of the sphere's parts from a place to its contrary place as a local and limited process, namely as a kinesis. Accordingly, he qualifies the unlimited rotation of a heavenly sphere as a kinesis according to its parts. Considered from the point of view of the sphere's parts, the sphere's rotation of fall between contraries is incomplete and is therefore a kinesis. Of course, the application of the concept of kinesis to the motions of the parts of a continuously rotating sphere requires some adjustment. Since these parts never stop, the termini ferrata of their change, unlike those of all sublunar changes, are instantaneous states, not states of rest. For rest occurs in time, not in an instance of time. In other words, the beginning and end of the motion of a part of a sphere are termini and ferrata of change in potentiality, not in actuality. Furthermore, Aristotle applies the notion of potentiality to the parts of the sphere and their places too. And this is because a heavenly sphere is a unitary and homogeneous body whose parts are numerically distinct from each other in potentiality, not in actuality. And since these parts are in potentiality, their places are in potentiality too. And this is point 13 of my handout. As was said, some things are in a place according to potentiality, while others according to actuality. Thus, when a thing with like parts is continuous, the parts are in a place according to potentiality, whereas when they are separate but in contact, like a heap, they are in a place according to actuality. So both the parts of the heavenly sphere and their places are respectively parts and places in potentiality. In sum, Aristotle applies the notion of kinesis to the unlimited rotation of a heavenly sphere derivatively, that is, according to the sphere's parts. Because of this, and because the unlimited rotation of a heavenly sphere is a unitary process of a unitary subject, he understands the sphere's parts as potential parts that change their potential place and move from a potential paras to another potential paras. Thereby, consistently with his general account of the unlimited and the continuous, he conceives the unlimitedness of the sphere's rotation as potential unlimitedness. Each limited change is followed by a limited change, which is followed by a limited change, and so on continuously. And this is point 14 of my handout. In general, the unlimited exists thus, because something different is always taken. And although what is taken is always limited, however, it is always other and other. Arguably, this is why throughout Physics 8, as well as in Metaphysics Lambda, Aristotle labels the rotation of the heavenly spheres as the only continuous change. he understands it as the continuous iteration of limited changes. Clearly, all this amounts to a considerable adaptation of Aristotle's account of kinesis, and one might wonder why Aristotle does it. Why adapt the notion of kinesis to an unlimited process rather than understand it as something different from a kinesis? This question can be answered by appealing to the unity of Aristotle's physical theory. This is the theory of all sensible and movable things, both perishable and unperishable, which are explained by means of the same principles. Therefore, if the heavenly sphere's unlimited rotation were not in any sense a kinesis, the possibility of explaining natural perishable entities and natural eternal ones with the same principles would be undermined, and with this, the unity of the science of nature. So it is necessary for Aristotle to extend and adapt the notion of kinesis to the heavenly sphere's unlimited rotation. Further, it is necessary to adapt it in a way that saves all the essential features of kinesis. And this is something that his account of the unlimited rotation as a kinesis according to the parts accomplishes. Instead, the hypothesis proposed by other scholars that the unlimited rotation is an abnormal kinesis that does not unfold between countries or that has some properties of energia would not work. For a process that does not unfold in any sense between countries is not an abnormal kinesis. Rather, it is not a kinesis at all and cannot be explained in terms of privation and form, understood as first countries. The same goes for a kinesis that has some properties of the energia, especially if these properties are those that distinguish the energia from the kinesis. By contrast, understanding the unlimited rotation as a kinesis according to the sphere's parts and using the notion of potentiality allows Aristotle to retain all the essential features of kinesis, as well as to integrate the notion of unlimited change into his general account of the unlimited qua potentially unlimited. In sum, the main reason why Aristotle extends the notion of kinesis to the unlimited rotation of the heavenly spheres by adapting it in the above-mentioned way is that by doing so, he can explain perishable and unperishable natural entities by the same principles, ensuring thereby the unity of the science of nature. However, as we're now going to see, ensuring the unity of the science of nature in this way also opens the door to first philosophy. For one of the principles of the unlimited change, namely its mover, cannot be a physical entity. Once Aristotle has extended the notion of kinesis to the unlimited rotation of the spheres, he applies to the latter the following thesis, and this is point 15 of my handout. First, every body that is in motion is moved by something. Second, every change of limited changes is caused by a self-mover that comprises an unmoved mover and a moved. Third, every mover has a dunamis whose quantity is directly proportional to the size of the mover and to the duration of the movement that the mover causes. It is important to note that prior to applying this thesis to the unlimited rotation of the spheres, Aristotle introduces and elaborates them by considering limited changes alone. Thesis 1 derives directly from the definition of kinesis as the actuality of what is potentially qua such, which, as we have seen, applies to limited changes. The implication is shown by the fact that, as Aristotle stresses in Physics 3.3, according to the definition of kinesis, the actuality of the moved is one with and identical to the actuality of the mover. He makes this point even more explicit when, at the end of Physics 3.3, he provides a gnorimateron formulation of his definition, which includes both the patient and the agent. And this is point 16 of my handout. he claims that kinesis is the actuality of what is in potentiality, patient and agent and such. Now, in Physics 8, Aristotle elaborates thesis 1 in chapter 4. There, however, he does not use his definition of kinesis to justify this thesis, but an inductive argument. Significantly, in this inductive argument, he considers several types of limited changes to show that each of them is caused by a mover. Forced limited changes of sublunar self-removers, and natural limited changes of simple sublunar bodies. Aristotle applies thesis 1 to the unlimited circular motion in chapter 6. Thereby, he deduces that, like limited changes, and insofar as it is self a change, albeit only with respect to its potential parts, the unlimited rotation is caused by a mover. In particular, since the unlimited rotation is a numerically unitary change, and since a numerically unitary change requires a single mover, Aristotle infers that the unlimited rotation is caused by a single mover. And this is point 17 of my handout. It is evident also from this that the first mover must be something that is one and eternal, for it has been demonstrated that there must always be motion. But if motion always exists, it must be continuous, for what is eternal is continuous, while what is successive is not continuous. But now, if it is continuous, it is one. But one is the motion of one moved, and that is caused by one mover. For if one thing, then another, is to cause movement, the whole movement will not be continuous, but successive. Now, clearly, this argument does not yet lead out of the science of nature, because what has been said so far is still compatible with the hypothesis that the mover of an unlimited change is a physical entity. The characterization of the mover of an unlimited change as a non-physical entity occurs with the application of theses 2 and 3 to the unlimited change of the heavenly spheres. And like thesis 1, also theses 2 and 3 are elaborated by analyzing limited changes. Aristotle puts forward thesis 2 in chapter 5. According to this thesis, every change of limited changes is caused by self-mover that comprises an unmoved mover and a moved. This means that the notion of a mover is introduced in relation to limited changes. More precisely, the unmoved mover is primarily understood as a part of a self-mover of limited changes. Furthermore, Aristotle derives the hypothesis that a self-mover comprises a moving part and a moved one, also from the definition of kinesis. Since a kinesis is incomplete, it is necessary that it be caused by something distinct from the moved, namely by a mover which, unlike the moved, is completely in actuality. And this is point 18 of my handout. Further, we have established that it is the movable that is moved, but this, namely the movable, is moved in potentiality, not in actuality. And what is in potentiality proceeds towards actuality, and change is the incomplete actuality of the movable. But the mover is already in actuality. For instance, what is hot heats, and in general, what has the form generates. So the same thing will be hot and not hot at the same time and in the same respect. And likewise, which with each of the other things in which the mover must have the same name as the moved. Therefore, of what moves itself, one thing moves and the other thing is moved. Now, by applying thesis 2 to the unlimited rotation, in chapter 6, Aristotle deduces that the unlimited rotation is caused by an unmoved mover. This step, however, involves a significant modification of the concept of immobility and therefore of a unmoved mover. While the unmoved mover of a limited change is unmoved per se, but not per accidents, the unmoved mover of an unlimited change is unmoved both per se and per accidents. Indeed, according to Aristotle, only a mover that is unmoved both per se and per accident can cause an unlimited change, because only such a mover is eternal and always active. And this is point 19 of my handout. On the basis of these considerations, one can be persuaded that if something belongs to the class of things that are unmoved but move themselves accidentally, it is impossible that it causes a continuous motion. So if it is indeed necessary that there be motion continuously, there must be a first mover that is unmoved also accidentally. Now, the unmoved movers of limited changes, that is, the unmoved movers that are parts of sublunar self-movers, are movable by accident because they are in motion when the body they move is in motion. Furthermore, these unmoved movers are not eternal, but they are generated and corrupted by accident when the body of which they are unmoved movers is generated and corrupted. And lastly, they are not always active, not even during the time they exist, but they pass repeatedly from inactivity to activity, and these transitions are due to environmental factors. Therefore, an unmoved mover that moves always, namely that is always active, must be unmoved both per se and per accidents. And this puts it outside the domain of nature and of physics. Insofar as it is eternal and absolutely unmoved, such a mover is outside of time. So it is timelessly eternal. So the extension of the notion of a mover from the scope of limited changes to that of unlimited ones involves leaving the domain of physics. Now, with the last argument in chapter 10, Aristotle concludes that the unmoved mover of an unlimited change is without parts and magnitude. It is an indivisible entity. In this argument, he uses thesis 3. Every mover has a dunamis whose quantity is proportional to the magnitude of the mover and to the duration of the movement that the mover causes. This thesis, like the other two, is clearly elaborated on limited changes. It derives, among other things, from the observation that all other conditions being equal, a mover of magnitude 2x moves a mover y for double the time of a mover of magnitude x, and therefore has a dunamis whose quantity is double compared to the mover of magnitude x. For instance, a hot body whose magnitude is 2x will heat a cold body for twice the time compared to a hot body whose magnitude is x. Now, by applying this thesis to the mover of an unlimited change, that is, to a mover that moves for an unlimited time, Aristotle infers that this mover has an unlimited dunamis, and that therefore it either has an unlimited magnitude or is devoid of magnitude. He excludes the hypothesis that it has an unlimited magnitude because in physics 3 he had already shown that there is no unlimited magnitude in actuality. Hence, he concludes that the mover of an unlimited change is without magnitude. And this is point 20 of my handout. These are the last words of the physics, of the whole physics. Now that these points are established, it is evident that it is impossible for the first and unmoved mover to have any magnitude. For if it has magnitude, its magnitude must be either limited or unlimited. That there cannot be an unlimited magnitude has already been proved in the physical treatises. That a limited magnitude cannot have an unlimited power, and that something cannot be moved for an unlimited time by a limited magnitude has just now been proved. But the first mover causes an eternal motion for an unlimited time. It is evident then that it is indivisible and without parts, and that it has no magnitude. In sum, with respect to limited changes, Aristotle understands the dunamis of the mover as limited and connects it to the limited magnitude of the mover by means of a relation of direct proportionality. Instead, once he applies the notion of dunamis to the mover of an unlimited change, he understands the dunamis as unlimited. He dissociates the dunamis from the magnitude, and therefore he attributes the unlimited dunamis to an entity that is both timeless and dimensionless, namely to a non-physical entity. So I shall come now to the conclusion. Insofar as he uses physical arguments to arrive at a non-physical first cause, Aristotle's position is completely anomalous compared to the previous tradition. Those who inferred the first cause or causes from physical arguments understood it as a physical entity, most of the previous physicists. Conversely, those who posited a non-physical first cause or causes inferred it from non-physical arguments, like the Pythagoreans, Plato, and the Platonists. However, Aristotle's heuristic path can be compared to the one that led some contemporary physicists to the hypothesis of the initial singularity from which the Big Bang originated. The initial singularity is understood as the principle, in this case also temporal and material, of the current physical world. It is a hypothesis derived from the observation of physical phenomena and from the application of physical laws back to the first cause of the universe, the singularity, which is conceived as a point where all physical laws that apply to its effects break down. In this case, though, there is no transition to a science different from physics, above all because modern and contemporary physics, unlike Aristotle's, is not based on an essentialist notion of natural entity, and therefore is compatible with the existence of physical domains that have different physical laws. In short, the initial singularity can be understood as a physical entity subjected to physical laws different from those of the universe that originated from it. Hence, the reason why the series of arguments that Aristotle develops in Physics 8 leads to something non-physical includes some basic assumptions of his natural science. In particular, is essentialist notion of natural entity, from which it follows that all natural entities must be explained on the basis of the same fundamental principles. Of course, further investigation is needed for this analysis to provide elements to better understand the status and properties of the first cause. Since Aristotle infers the first cause from the unlimited rotation, it is first of all necessary to clarify the status of the rotating heavenly spheres from the point of view of the distinctions between privation and form, potentiality and actuality. Further, it is necessary to understand what the unlimited rotation is when considered according to the whole, and what the relations there are between the first cause and the unlimited rotation considered both according to the parts and according to the whole. An inquiry along these lines might provide elements to better understand the status and properties of the first cause, since it might enlarge the set of relevant data by heuristically and conceptually grounding in a clear and traceable way Aristotle's first philosophy on his physics. Thank you very much for your attention.
Thank you, Diana, for the lecture. We are now in time for questions. We'll start with Lucas because he has somewhere to be, so he won't be able to stick with us all the way through the end. Then we'll have Roberto, and then anybody from the audience, if you'd like to ask a question, please, you may be able to do so shortly. Lucas?
Thanks, Daniel. Thanks, Diana, for the paper. I think it's really convincing. I'm convinced of the main things of the paper, but I have two small questions. The first question is about the need you have on insisting that your solution is different than other solutions that have relied on the notion of abnormal kinesis, and saying that the unlimited rotation of the spheres is a kind of energia, share some properties with energia. I'm not very sympathetic to those views either. I'm just asking for the sake of clarification, but I wonder whether your account can be somehow accommodated with saying that the unlimited process, the unlimited rotation of the heavenly spheres are in a way kinesis, and then this somehow covered by the notion of abnormal kinesis. A lot depends on what we put into this notion of abnormal kinesis. But if you construe it just in the sense of something that is kinesis, but with a small addition of, let's say, conditions, like not applause, but pause or pair in a way, I think you are closer to this notion, and then I can see exactly the difference between your solution and the solution that resorts to this notion of abnormal kinesis. Because saying that the unlimited rotation of the heavens does not unfold in any sense between countries, I think it's not what you want, because they unfold between countries according to the spheres parts and according to this notion of potential part. Then it seems that you might be closer than you might want to this notion of abnormal kinesis. This is the first question. I don't know if I should ask the second question right now or after you answer the first one.
Yeah, okay, you can answer the first one so that I have it clear in my mind. Thanks. Thank you very much. This is an important question. Actually, you are right. There is a sense in which my account describes, although my interpretation, the unlimited rotation of a sphere is an abnormal kinesis. The main difference lies between my proposal and that of other scholars is that while other scholars claim that do not make the difference between kinesis according to the whole and kinesis according to the parts. So without making this distinction, the result is that you have to combine properties of the kinesis with properties that are not of the kinesis and attribute them to the same subject. So the whole process is somehow a kinesis and somehow it is not, and it lacks exactly the features that are necessary for something to be a kinesis, so unfolding between countries. But if you have this distinction, if you put in place the distinction between parts and whole, that is kinesis according to the parts but not according to the whole, then you have a subject, the parts, which really unfold between countries, although again, there is this further adjustment in potentiality. So the very point of the distinction is that on my interpretation, which is mainly based, as you have seen, on physics 4.5, where Aristotle focuses on the place of the heavenly spheres and the locomotion of the heavenly sphere. So according to this passage, what is relevant is identifying exactly what is the subject, the primary subject of the kinesis. If you identify clearly the primary subject of the kinesis, that is the parts, then you can apply the definition without changes to the definition, and you can still keep thinking of the kinesis according to the parts, according to the definition of kinesis, and describe it as something that unfolds between countries. And then of course, then you have a further problem. What is the rotation of a sphere according to the whole? I've argued elsewhere that according to the whole, the rotation of a sphere is an energia. And again, my proposal seems close to what others have claimed. But whereas those who claim that it mixes properties of kinesis and energia, I don't claim that it mixes properties of kinesis, but because this would amount to a contradiction. How can there be something that is somehow a kinesis and somehow an energia, if being an energia is incompatible with being a kinesis? But if you clearly find the respect in which it is a kinesis and distinguish the respect from the one according to which it is an energia, that is, according to the parts and according to the whole, no contradiction results. I hope this was clearer.
Yeah, yes, that's very helpful. That's very clear. I'm satisfied. Well, I have a second question, a second concern. It's not exactly related to anything you have said in the paper, but that's something lurking around or behind this whole project, which I would like to hear your thoughts on this. So, saying that Aristotle starts with physical objects, physical characteristics, etc., and arrives at a non-physical principle, might raise some thoughts about, well, is not some kind of crossing happening here? I'm just wondering about this. I have my views on this. I'll not be concerned about this at all, but I wonder whether you have some thoughts on this as a potential problem lurking around this whole project, because it's in some construal of crossing, the issue of crossing, given discipline should have all the terms involved in the explanation belonging to the same genus, but then the problem revolves in terms of what we should understand by genus in this case. But in some construal of the picture, one might say that, well, now we have a principle that is a non-physical entity explaining something in the domain of the physical entities, and this might be a problem. Aristotle probably changes his mind, etc., etc. I don't know why it happens, but I would like to hear what you have to say on this issue.
Yeah, thank you, Lucas. That's again very interesting. Well, I would distinguish between the issue of crossing when it concerns the route from the principles to the explanandum, and the route from the explanandum to the principles. Now, as Aristotle, so this is a distinction he makes in the Nicomachean Ethics. So I'm not sure whether the issue of crossing applies to both routes in the same way. It is one thing to use physical principle that have been already established to explain something that does not belong to physics, or to use principle belonging to a science to explain things that do not belong to a science. It is another to use principle of a science to reach, to heuristically found and ground another science. And this is something that Aristotle does both when he grounds his first philosophy and his mathematics, because also mathematics is a science that whose roots are in the physics. So mathematical objects are obtained from physical object by means of apeiresis, which of course is a different procedure from the one we find in physics 8, but is from the procedure that leads from physics to first philosophy. But in the case of first philosophy, Aristotle is especially, so he shares with the Platonists the idea that the first cause of nature is something non-physical, right? But what he disagreed with them about is how to arrive at the first cause. And he criticizes them for using mathematics or also mathematics in order to arrive at the first cause. So he's very sure and committed about the routes he thinks correct to follow in order to arrive at the principle of all things. And this route is, in his view, must be a physical route. So I'm not sure. So insofar as the first cause is something that is not perceivable, that it is an hypothesis, you cannot perceive it, it's not an object of experience. So the only way you have to arrive at it, to formulate the hypothesis that it exists and to attribute to it some properties is from something that you observe. And in his view, you must do this from physical entities. So kind crossing in this case is simply necessary. There is no other way to arrive at something non-physical in a scientific way, but other than from physical premises. So of course, this is a big issue, that of kind crossing, but again, I would distinguish between the issue of kind crossing insofar as the route towards the principle and the route from the principle is concerned. And I would say that when you want to, when your attempt is that of grounding a science whose first object is something that is outside your experience, outside your perception, then the only way you have, scientific way you have, besides faith, it's that of arriving at it through something you perceive. And so since something you perceive is an object of another science, there's no way of avoiding kind crossing.
Okay, thank you very much.
Well, thank you very much, Lucas and Diana. So Roberto said he had some problems with his internet. Roberto, would you like to ask a question?
Yeah, I hope my connection is stable enough, but we'll see. If I disappear, it's just internet problems. So first, thank you very much. It was an occasion for me to learn about some parts of the physics I'm not too familiar with. So my question is probably a question for Aristotle. So it's not probably an interpretive question, but on the other hand, I thought maybe the reason why I have this question is that I have some misunderstanding of the argument, so it might be useful anyway, and maybe can be interesting at any rate. So I will ask this question. So my question is about why is this circular motion of the heavens, why is it exceptional in comparison with the motions of sublunar bodies? What I mean is, I suppose that Aristotle would say, if I ask Aristotle, what is the reason why fire always goes up? It's just the nature of this elemental body, which is fire, to go back to its natural place, okay? So I wonder why, in the case of the heavens, assuming that Aristotle was believing, as it seems in the Caelo, that they are made of a fifth element, which has a natural tendency to move circularly. Okay, so assuming this, why do we need this immaterial principle explaining the motion of the heavens? And by that, it's still there, even if I assume that in the case of the four sublunar elements, we have going back to a natural place, as the motion is going back to a resting place. while on the other hand, the heavens are moving like an activity, and they are not like seeking a natural place where they can rest, so to speak, okay? And the reason is, in the same way as I need that principle to explain why the movement is eternal and unlimited and always there, I could say, yeah, but fire will always go back to the natural place, eternally go back to that natural place, so the place like above the other elements. So do we not need there as well some immaterial principle that explain this eternal tendency to go back to that place? But again, maybe there's something very wrong in the way I'm understanding the argument. So if this is the case, I would like to know what I'm getting wrong. Or maybe it's just a question for Aristotle. So.
Thank you, Roberto. No, it's not at all a wrong question. Actually, it's a question that several people are asking since decades. Why does Aristotle need the first mover if the heavens are made out of the first body which naturally moves eternally? So this is a big problem. It's a big problem because the first problem is about on the heavens, because the standard view is that on the heavens there is no trace of the mover. If this is right, then really Aristotle, in a certain period, when he wrote the cello, believed that there was no need of a mover for the heavens to rotate continuously and eternally. So this is the standard view. Personally, I'm not persuaded by the idea that the cello does not contain any reference to the mover. And this is something I would like to not to prove, but would like to write on this, showing that there are several passages of the cello which are based on physics 8. And it's very clear, in my view, that they are based on physics 8. So if they are based on physics 8, I think that it is unlikely that being based on physics 8, the cello does not have, endorses the view that the heavenly bodies rotates only because of the kind of matter they are made out of. But this is another story. So the first point is, the first problem is really that the cello admits the possibility for the heavenly spheres to rotate without having a mover. If the answer is yes, then really perhaps Aristotle changed his mind. If the answer is no, then he didn't change his mind, and so we have to try to answer the question anyway, independently from the decay law. Why does he need? So my answer, I would try to answer the question on the basis of physics 8 alone. So as far as I can see, the strategy Aristotle adopts in physics 8 is that of trying to understand what this unlimited process is by means of analogies with processes, already known processes of ordinary experience, processes that he already tackled in his previous investigation. So you have something unknown that you need to explain and to conceptualize somehow. And from a scientific point of view, is quite a reasonable way to behave, that of trying to understand something unknown on the basis of something you already know. And this is basically the procedure I think he adopts in Physics 8. So he first of all tries to adapt the notion of kinesis to the unlimited rotation of the spheres, and then tries to apply to the unlimited rotation of the sphere theses that are valid for limited change. So everything in motion is moved by something, and every change of limited changes as a mover, and the third thesis about the dunamis, either limited or unlimited. So the short question would be, he arrives at the conclusion that the unlimited rotation requires a mover because the unlimited rotation is a kinesis according to its parts, and every kinesis is caused by a mover. So it is simply a sequence of inference. If the unlimited rotation is a kinesis according to its parts, then being a kinesis, and since every kinesis is moved by a mover, then also the unlimited rotation requires a mover. Of course, there is an additional problem with all this, which I pointed out in some notes, that the second thesis, that every change of limited changes is caused by an mover, is a thesis that Aristotle derives from the analysis of sublunar self-movers. So in the case of sublunar self-movers, the unmoved mover is always a part of a self-mover. Whereas, again, according to the standard view, when it comes to the unlimited rotation of the sphere, the unmoved mover is something separate, is not anymore a part of an unmoved mover. There have been some scholars, unorthodox scholars like Cosman and Sarah Brody, Waterloo Brody, who argued that perhaps the unmoved mover is not a separate entity, but also the heavens are self-movers. But this is an unorthodox view. So if Aristotle if the standard view is correct, there is another leap in the argument. So he applies the notion to, he first of all infers that being a kinesis according to its parts, also the unlimited rotation needs a mover. So it cannot be something that simply because it is made out of the first body goes on continuously. And this mover must be an unmoved mover, but unlike the unmoved movers of the sublunar entity, is not a part of a self-mover, but is something that is separate from it. And so this would be a further adaptation of the physical basic picture to the case, the difficult case of the unlimited rotation. I hope I managed somehow to reply to your question.
Yeah. Now I have even more doubts because you had some this second leap as well. So, but again, I suppose it's a hard question, and it's something that goes beyond the interpretation. I mean, I have no reason to question your interpretation. I'm perfectly convinced. But then there are these questions of,
yeah, sure.
It looks like he knows that there is this prime mover there, okay, and some way is justifying by a process of inference and analogies with the, not the physical world, the sublunar physical world, how we could argue that there is this prime mover, but there are these leaps that maybe, I don't know, someone may say there are leaps of faith, always, maybe, but I don't know, but it's a hard question, I guess.
It's a very important question. I think so. I deliberately left it outside the scope of my paper because, you know, when you tackle things that have to do with Aristotle's first philosophy, it is such a chaos that it is very difficult to find your way without making troubles everywhere. But one thing I would like to add, if you are right that, and many people think that, I mean, why the first movement? If this is something Aristotle has really no grounds to introduce, then he doesn't have any first philosophy anymore. Because if you can explain everything with the matter of the heavenly spheres, then natural science is first philosophy. There's no, and if we don't try to find an answer to these questions, then we don't have really grounds for thinking that Aristotle was right in having a first philosophy different from physics.
Yeah, even more difficult than I was thinking. So thank you. I will keep thinking for a long time about that, I guess. But thank you very much.
Thank you.
So we have one student, Matheus Jurandir. I think he's trying to ask us a question. He did so in English, but I'm not sure I got what he's trying to ask. So I asked him to write the question in Portuguese in order for me to translate. In the meantime, does anybody else has a question for Professor Diana? This is the time. Anybody? I guess everybody was convinced, not only Lucas. Okay, Dashan. I hope I have pronounced your name right. Welcome. Please ask your question.
Thank you, and thank you, Diana. I have a question about the part and whole relation in the sphere's rotation. Well, I guess my question would be, if all the parts are potential parts, and therefore, and they are the subject of kinesis, and therefore the kinesis, the unlimitedness of kinesis is also potential. However, we can only observe stars moving. That is, we can only observe parts of the sphere moving. So then somehow Aristotle also believes that even though we can only see the stars moving, the things that is in contact with the stars are the ones who are also moving. Then I wonder, why do we see stars as potential parts of the sphere? Because clearly they have other things that distinguish them from the other parts of the sphere, so that we can see only parts of the sphere moving, even though Aristotle argues that it is a whole sphere that is moving. Yeah, thank you.
Thank you. This is a very important question. Actually, Aristotle's account of the continuous, of what the continuous is, implies that if you have a body that is homogeneous, then so homogeneity implies continuity. In order to have to claim that two things are in contact and so numerically distinct from each other, this must be heterogeneous, made out of a different matter. So this is a problem. I think this is a problem for his account of continuity, because it implies that if I put two blocks of marble together, his account of continuity as based on homogeneity implies that they are one block of marble, a continuous block of marble, not two. So I think that this is a problem in his theory. And as far as I'm aware, but I should check more in the Meteorologica, he doesn't provide an answer. So he clearly believes that, so that there are heavenly spheres. Of course, it is an hypothesis. we don't see the heavenly spheres, we only see stars and planets moving. So he hypothesizes that there are heavenly spheres, both because the astronomy of his time believed that, and because he thinks that only a rotating sphere can move unlimitedly. And so whereas a body, so if you think according to our astronomy, a body that moves in a circle is not moving circularly in his sense of moving circular, is moving along the circle, but not circularly. So he has this hypothesis that there are spheres, but we don't see these spheres. And he also has the hypothesis that these spheres are made out of the first body. And since the planets are parts of the spheres, they are made out of, so there is no irregularity, no material difference in the spheres. They are all made out of the same matter. And as far as I'm aware, he does not provide, but I should check more in the meteorological if there is an answer to the, he does not answer your question. Why is it that we perceive the sun, but we don't perceive the heavenly sphere, if the heavenly sphere and the sun are made out of the same element? So I haven't found an answer to this question.
Okay, great. And just to follow up, and he believes stars and planets have magnitudes, right?
Sure.
Okay, but then how can something of a magnitude be part of a sphere?
Because the sphere have magnitude too.
Also, the sphere also have magnitudes. Okay,
Yeah,
so it's not like, so they are not like a point on the surface of a ball. That's not how he sees it. Okay, I see.
The spheres have magnitude. What lacks magnitude is their mover.
I see. Okay, that's great. Thank you. Thanks.
Thank you.
Thank you, Dashan, and thank you, Gianna. Okay, so I think I got the hang of Mateo's questions. I'll read it to you, see if you can understand. So I think it's clear now. He asks the following. He says, as you have argued, the conception of the prime mover is a consequence of the necessity to explain natural entities on the same principles. And he adds, and that is Mateo adds, of his conception of movement, which is based on substantial forms, internal principles, and the search of maximum excellence of being. And his question is, do you think Aristotle's theory of movement implies an animism in the sense that physical entities must have some degree of consciousness of what is best for each of their telos, he means, considering also the problem which is stated in De Caelo 2:12?
Thank you, Matthews. Yeah, so this is a question about Aristotle's teleology. I don't think that, so consciousness is a difficult word to match on Aristotle's philosophy, but so I think we can be pretty sure that there is no consciousness to reach a telos insofar as, for instance, sublunar bodies reaching their natural place is concerned. There is no consciousness in a plant developing to its complete form. Whereas insofar as the unlimited rotation of a sphere, well, it is a matter of debate. What relation? So, what is the life of? So, Aristotle attributes life to the heavenly spheres, and insofar as physics 8 is concerned, there is only reference to their continuous motion, not reference to their life. Of course, if the standard interpretation is mistaken, that is the view that the heavens are not self-movers, but are moved by an external mover, then insofar as physics 8 is concerned, you can only say they just move continuously without consciousness of anything. Instead, if Aristotle's account in physics 8 does not imply that the mover is an external entity from the heavens, but it is part of a self-mover, recall that in physics 10, Aristotle claims that the mover is in the circumference. He does not claim that it is outside. He makes two options. Either the mover is in the center of the universe, or it is on the outermost circumference. So in physics 8, he's not claiming anything about the mover being outside. So and so what he claims in physics 8 about the heavenly sphere and the fact that mover is in the circumference is, from this point of view, compatible with the spheres being self-movers, having the mover as a part of them. And if they are self-movers, since all self-movers are animate beings, then they are animate beings according to physics 8.2, which, however, does not imply being animate things, does not imply by itself having consciousness of the telos they try to reach. And this is something that the question whether they have consciousness is something that has to do with the relation there is between their moving and their thinking. Because the heavenly spheres also think. Aristotle attributes a kind of thinking to them. But what is unclear is the relation between their moving continuously and their thinking. But this is perhaps also the same problem we have with the mover, which is something that moves and something that thinks itself. What is the relation between his moving and his thinking? So I would say that insofar as teleology is concerned, there is no need for several teleological processes of the sublunar realm to have consciousness of their telos. And this holds for plants, and this holds for sublunar simple bodies. Insofar as the supralunar realm, the heavenly spheres, understanding what does it mean for the heavenly spheres to be conscious, or whether they are conscious of their the telos they try to reach, is the same as trying to understand what relation is there between their continuous eternal motion and their thinking. So I'm replying to most of your question only by trying to sketch what the route, in my view, to find a reply to this question might be. I'm not providing clear-cut answers, because, as you know, these are very highly debated topics, and it is useless on my part just to say, oh, my view things are in this way, without providing also proofs that my view is correct. So since these are very difficult topics, what I can say is only what I would, how I would investigate these points. I hope it suffices.
Thank you for the answer. We have one more question already by Samana. Samana, please. Where are you? There you are.
Hello, thank you, Diana. Very interesting. But I need to tell you, I tried to read the physics little, okay? And when you say for me about a lot of concepts together, like dynamics, kinesis, telos, and I'm reading the anima, you know? Now you put more limits for me about the difference to sublunar, telos in sublunar. I don't know. The point is, sorry, my question is confusion. If you can talk more, where your point, and you talk about continue, you know, this, a lot of concepts together in the same time. I don't know, sorry, my question is not too much objective, but if you can talk about, try to correlate these four concepts like telos, kinesis, dynamism, and continue. You know, this make a or not. Thank you. Sorry for my confusion.
No. So I try. So first, let's start with kinesis. Kinesis is change. Change is something that unfolds between a starting point and an end point. Every kinesis, every change is from something to something. There must always be a telos. So a final point where the change stops. For instance, a plant from the seed grows and then it reaches the telos, the mature form of the specimen, right? Or something passes from being cold to being hot. And all these changes are limited. They start from one point and finish to a point. And changes are caused by a mover that in most cases has already in actuality the property or form that the moving thing will have at the end of the change. For instance, a human being generates a human being, or a cold thing, a hot thing heats a cold thing. So the mover has already the hot in actuality and activates the potentiality to become hot in the moved. So here we have put together kinesis and telos, right? So further, let's put the continuous in it, connect also the notion of continuity. So every change is in a way continuous, in the sense that from the starting point to the end point, the process is continuous without any interruption. Of course, it might be that it is interrupted, but if something, for instance, starts becoming hot, then it stops for some reason, and then again starts again, and in the end becomes hot. This is not one single change, but two changes, because there is a pause in the middle, right? So this is the first conception of what is continuous. You have a limited change that is continuous because it is divisible ad infinitum. You can divide ad infinitum, like also a pen is a continuum because you can divide the pen ad infinitum. This is a continuum. But in Physics 8, Aristotle uses the notion of continuity in a different sense. It is a connected sense, but a different sense. Not simply the continuity between the extremes, but the continuity in the sense of continuing uninterruptedly. So he tries to see whether a change like something becoming from cold hot can be continuous in this second sense, proceed continuously. And he notes that this cannot be so, because in order first thing, if something is cold and it becomes hot, since hot and cold are contraries and are fixed qualities, you cannot becoming hot ad infinitum, because there is hot is a particular, a definite quality, is not something that has no limit. So something cannot be becoming hot and infinitum. When it reaches the hot, the form of the hot, then it stops. So one might think, okay, but something could change ad infinitum by becoming from cold, hot, and then from hot, cold, and then from cold, hot. So going repeatedly back and forth. But Aristotle argues that this would not yield a unitary motion, because when the body reaches the hot, before going back to the cold, it must stop. It cannot go back and forth continuously without a pause. So all changes that are between countries cannot be eternal, cannot continue indefinitely. But there is one single change, the rotation of a sphere, that can go on continuously, because if you think of the rotation of a sphere, you can think of it of something that moves from a point towards the same point. So it's not between countries. And if you think of this thing, the sphere, rotating continuously, you see that it is arbitrary to claim this is the starting point. Every point is at once beginning and end. So the sphere as a whole is not moving from a point towards another point, from a limit to another limit. But then the question is, how can you claim that this is a kinesis if there is no starting point and there is no end point? A kinesis needs to have a telos, needs to have an arche. And the way Aristotle tries to accommodate this eternal rotation within his account of kinesis is that of distinguishing between change according to the whole. And so the rotation of a sphere according to the whole is not a kinesis. There is no end point and beginning point. But according to the parts, if you try to isolate a part of the sphere, you can see the part moving, occupying different positions. And if, for instance, you consider this part moving from the extreme of the diameter to the other extreme of the diameter, these are, from a geometrical point of view, contours. And so you can account for the rotation of a sphere as a kinesis, so as something unfolding from a beginning and an end according to the parts. So by isolating virtually, because these parts are there only in potentiality, not in actuality. So if you consider the rotation of a sphere from the point of view of the whole, this is something, the sphere is something that is always in the telos. Is always in the same place, but it is dynamically in the same place and in the telos, continuously in the, not, for instance, I am a mature human being. I have reached my telos from a biological point of view. And this is a state, although my organism is continuously keeping this telos there. Likewise, the sphere is continuously keeping its being in the telos. Whereas from the point of view of the parts, you can distinguish between beginning and end. And you can claim that the sun is now in this place and now in the other. When the sun rises, it is at an extreme of the diameter, and when it sets, it is at another extreme of the diameter. And this is, strictly speaking, a kinesis, because it unfolds between countries, and there is a beginning and an end.
Beautiful explanation, helpful a lot. I think you explained me so clear now. Amazing, thank you.
You're welcome. It was a pleasure.
Okay, so anybody else? We have somebody here asking you to clarify a little bit more about consciousness and how it's connected to thinking and movement. I'm not sure who it is because it's a telephone number, I think. But this is it. Roberto and Lucas apologized, they had to leave early. Lucas had a thesis he had to argue against. Roberto, I'm not sure. So if you could say a little more about that to 862158988627.
Okay, sure.
Welcome.
So again, so again, this is a major problem. There is a passage from De Anima 1 where Aristotle, so we have good reasons to believe that in Aristotle, the spheres both move and think. The question is what the relation is between their moving and their thinking. And there is a passage from Aristotle's De Anima, book 1, where he criticizes Plato for identifying thinking with moving circularly. And this is a very difficult argument, but I think that should be among the texts that we would need to clarify and to get clear about to understand better what the relation is between thinking and the moving of the heavenly spheres. But apart from this, I'm sorry, I don't. So I think in this case, in the case of this very difficult topics, the first steps are especially difficult and involve clarifying the answer itself. And clarifying the answer itself is part of clarifying the question itself, sorry. And clarifying the question itself is part of what I'm trying to do with this project, part of which is the draft you have read, that is trying to bring Aristotle's first philosophy and more generally also his account of the supralunar world closer to his physics, sublunar physics, because since sublunar physics is much more developed and clear to us, and since there are clear links, at least so I've argued, between his sublunar physics and supralunar physics, but this link involve adjustments, modifications, in order to understand these more difficult topics, those concerning, first of all, the first mover, but also the thinking and moving of the heavenly sphere. We need to understand first very clearly how the basic concepts are introduced and how they are modified when they are applied to this more complicated and far from us objects like the heavenly spheres and their mover. So again, I'm only suggesting path of research, not answers, but I think this is what I honestly should do in this place.
Okay, thank you very much, Diana, for a very clear presentation and some very clear responses. But Samara would like to say something, Samara?
I'm really satisfied now. It's an amazing answer. Thank you a lot.
Yeah, some people are congratulating you on the presentation on the chat. So I think that's a wrap. If nobody has any more questions, and I think they do, let me thank you again, Diana, for the presentation and for accepting your invitation, and thank everybody who has shown up here today. We should have, oh, Carolina would like to say something?
No, I was clapping.
Oh, you were clapping. I'm sorry. That was me. I didn't see the difference between the hands raising and the clapping. Okay. So that's it for today, everybody. I'll send you a message with our next presentation soon. We're just confirming the dates. As soon as I have them, you have them too. Thank you very much and hope to see you soon. Bye-bye, everybody.
Thank you for the question. Thank you for the invitation. Goodbye.